Alright. This integral has to be evil. This integral has to be evil because you can't use odd functions because there's an absolute value here. So this is the same, because it has an absolute value, it means that it is even. So it's 2 times the integral of 0 to 2. Yeah. And then this whole function here. I'm going to leave the x out. So let me leave the x out. Okay. And then some algebra, x minus 1 times x plus 1 is equal to x squared minus 1. X squared minus 1. And then x minus 2 times x plus 2 is equal to x squared minus 4. As you can see, we can do some u substitutions here. Do I want to make this, can I make this easier? So instead of just doing u equal x squared, I can try to manipulate the bounds maybe a little bit. Wait, okay. So I have -1 and -4. If I add 1, then add another 1, add another 1, damn, they're never going to be the same numbers. If I go backwards, so if I do -1, nope, they're not going to reach. Dang! Okay. Well, I can't cheat the system, unfortunately. So what I was trying to do is pretty much, I do a u substitution, where it's like x squared minus alpha x squared plus alpha, and then I could just go straight into this. But I don't know how to form it that way for a user. Oh, maybe I have to go rational. If I go rational, if I do okay, maybe it's not worth going rational unless you're very mentally gifted. But I'll just stick to u equal x squared. So then this goes to 0 to 4, u minus 1, u minus 4. Then we have to do expressions. This is 5u, -5u, plus 4. I think I did my math correctly. And then let me just rewrite everything. So we have from 0 to 2, u squared minus 5u plus 4 du. This is equal. Usually when I speed integrate, I don't like writing du. It's just redundant. But then this is just u cubed. I mean, the good thing is that the lower bound is 0, so we could just focus on the 2. So u squared 2 is 4u, and then we can just focus on 2 because if you plug in 0, it's just going to be 0. So then this is 8/3. I'm just plugging in 2. Oh shoot! I'm sorry. This is not 2. This is not 2. This is 4. I almost died. I almost died. Oh god. Well, 4 cubed is equal to 64 over 3. 5. So 5 times 16. That's 5 times. Oh, 5 times 16 divided by 2. That's 5 times 8. That's 40. And then plus 16. I like to leave my answer in this form. So 64 divided by 3 minus 24, I guess. 64 over 3 minus 24. That is my answer. 19 over 3. Okay, well, 64 divided by 3 minus 24. Uh-oh. I think this is incorrect. Wait, okay. And then 19 over 3. Yeah, this is incorrect. Oh no. I I screwed up somewhere. Uh, I'm gonna use Wolfram Alpha. Integrate. Wait, okay. First of all, did I want to know if this is a absolute value mistake or an algebra mistake. So from 0 to 2, technically that's what it is. Okay, so this is an absolute value mistake then. Oh, I'm so stupid. I miswrote it. Okay, wait. Okay, so negative. Okay, so that's what I got. So yeah, so this must be an absolute value mistake. This has to be an absolute value mistake. I am so confused. Wait, okay, hold on. Integrate the absolute value of x squared minus 1 of x squared minus 4 from negative 2 to, oh, shoot, negative 2 to 2. It is 19 over 3. Uh, why? Yes, it's an even function. Assuming x is greater than 0. Okay, well, I'll do that first step so that it can show me. Okay. Backed out. Okay, yes, I get it. All right, now what? You simplify. And what? Why did they take the x out? Oh, because x will never be negative from 0 to 2. Oh, shit. No. Oh, fuck. Okay. I see what we have to do. Oh, no. Oh, no. Oh, no. So, we did not get rid of the absolute value that quickly. So, there are conditions. So, be very careful when you deal things with absolute value. This is why I hate piecewise functions. This is so x will always be from 0 to 2, x will always be positive. So x, you can let x get out of the get out of that jail room, you know. So x squared minus 1, x squared minus 4. Okay. Now, this is not always positive. And this is also not always positive, right? So if I plug in 1, I'm sorry, no, if I plug in like a half here, this is negative. This is negative. If I plug in something like 3 halves, this is positive, but then this is negative. So what's going on is we literally have to split this shit in cases. And I like avoiding to do that. But unfortunately, we're gonna have to split this in cases. So, well, crap. Oh dear God. Oh, this is nasty. From 0 to 1. So x squared minus 1. So this is a negative times a negative. So this is positive here. Okay. You know what? Let me actually, to do this faster, you could just write f of x, because we already know what the function is. Okay. So we'll just do just for shortcut. Okay. Next, from 1 to 2. Okay. From 1 to 2, x squared minus 1 will always be positive. But x squared minus 4, from 1 to 2, this is going to be negative. This is negative because this will only reach to 0 or above 0 if x is like greater than or equal to 4. Then the whole whatever will be greater than or equal to 0. So because these numbers are less than 4, this portion is going to be negative. So that means that we have f of x. We have negative f of x. So because that's negative f of x, this is actually minus. Okay? Okay. Oh, shit. So then we get 0 to 1. So again, we're going to continue the u equal x squared thing. Then, oh, so u equals x squared. Just a reminder, and that du is equal to 2x dx, but I just never write that because, I mean, speed integration. So from 0 to 1, we get u minus 1, u, what am I doing? U minus 4. And then minus 1 to 4, u minus 1, u minus 4. Okay? Oh god. So we already know the antiderivative, kind of, if you remember the antiderivative. It's so the antiderivative. So when we already know that what this factor is, right? It's like 5u plus 4, right? And then the antiderivative is like u cubed minus 5 over 2 u squared plus 4u, right? So this portion will equal just 1/3 minus 5/2 plus 4, and then minus, and then, okay. So the lower bound is the same thing as this top bound, right? So what's going to happen is I'll get the antiderivative of 4 minus 1, right? This and this portion there. Let me just I want to get this, like, I just want to solve this quickly. But at the same time, like, I have to be careful to not leave you guys behind. This whole portion is equal to f of 1. So the answer, so we already done with this now. Okay, we're done with this integrand here. Okay, so our answer is 2 times f of 1, because we combine these, right? And then minus f of 4. Okay. Now let's delete this, and then plug in 1, plug in 4 to this antiderivative. So we get 2 times 1/3 minus 5/2 plus 4 minus 64 over 3 minus, it was 5 times 8, 40, plus 16. Oh my god! And then, this is negative, I'm just going to combine everything. Negative 62, 3, this is minus 5, plus 40, so plus 35. This is 8, 8 minus 16, negative 8. This is equal to, I don't know 35 minus 8. This is 7, 27. 27 minus 62 over 3. 27 minus 62 over 3. And if we go to Wolfram Alpha, it was, what did I got? 60, no, 27. 27 minus 62 over 3. Oh, 19 over 3. And there we go. Oh my god. Ugh. Terrible. Terrible. Very terrible. Oh god, I hate absolute value functions.